Good morning. How are you, Bill? I don't hear any audio. Maybe it's my side. I'll check here.
I can hear. Let me use.
Okay, I hear you now.
Yeah, doing okay. I get gonna have multiple.
Your audio is dropped out. I don't hear you speaking now.
How's that? Is that better?
It's better.
Okay. Yeah, let me see if I can adjust this a little bit. Test.
Hello.
Hey, guys.
Good morning.
Uh, hey,
Good
Brett
evening.
and Bill.
Good evening
Just
for
give us.
them.
It's actually good. Very nice. It's like 9 p.m. for us.
Yeah, I was going to say you're going to bed soon.
I mean, for uni students, we're kind of 9 p.m. is like early. I would say 1 a.m., 2 a.m. is kind of the usual,
All right. Well,
especially as we're approaching exams.
all
All
right.
right, can you give us 2 seconds? We're just double checking our camera so you can at least see a bigger photo of all the whole team. Is that okay?
Yeah, no problem.
All right, I'll just leave and join back in with the full team.
Okay.
So, Bill, I think you were talking a little bit about the procedures you got coming up. So, good luck with all that.
Yeah. I'll be fortunately in the hospital about a week here, day or two in ICU, and then probably get out the either the day before the competition starts or the day of.
So, you're going to be watching the live stream.
Yeah. Needless to say, I'm not going to Midland there.
Yeah, well,
But yeah, it was totally weird. I've had absolutely no symptoms or anything like that. They found it kind of as a chance, but I've got like all three of my arteries are more than 70% blocked, and one of them's 85% blocked. So
you need to fix that.
yeah. And the doc asked, the surgeon, when I talked to him, he says, "So can you walk a block without huffing and puffing?" And I said, "Well, I walk a couple miles a day with my dog, and up and down over, because I live out in the desert."
Yep.
It's going, I can't believe but so who knows what kind of energy I'll have after they fix me.
I'll bet you'll be climbing mountains.
Well, maybe not that far, but yeah.
So, have you been to the Midland site yet?
No, I have not. I have not. Um, been, of course, following all the discussion fairly closely, but I think it's actually going to be pretty good. The people in Midland, seem to have embraced us and are providing a lot more tangible support than like Las Cruces Visitors Bureau and so forth.
Yeah.
And the facilities, the um, convention center in Midland is much larger than the Las Cruces one, so we have more room and everything.
Yeah.
I'm
Nice.
muting my volume and microphone so that it's not.
Okay, so this is okay.
Hi, Brett and Bill. Can you guys hear us?
Yes.
Yep.
Oh, is that the
His phone.
his phone is the speaker?
His phone is the speaker and the microphone. Mine is no speaker, no microphone, so that it doesn't echo.
Okay, perfect.
Yeah.
You can move this mic and speaker here.
Because we'll be carrying it around.
Yeah.
Yeah.
How are you guys going today?
Yeah, we're doing good. We're doing good. Thank you for asking.
No worries. Yeah, we've had a pretty busy semester. We've got exams in about 2 weeks, and we also have the competition in about 2 weeks. So schedules are pretty hectic for us.
Yeah.
But I guess that's
know how that works.
that's something that all rocketry teams have. So we know that some of the eastern states of Australia teams, like University of Sydney, University of Queensland, University of Melbourne, are all struggling together.
Yeah, that will do it. Okay, well, since everybody's got a lot on their plate, let's get into it.
Yeah, no worries.
And team, if you just want to start at the nose and work your way back to the tail,
Yeah, no worries. Let me
describe your rocket and the main pieces as you go. And
yes.
Brett, feel free to jump in whenever if you got any kind of questions.
Yeah, perfect. So this is the nose cone. It's an LV Huck nose cone. It's 400 millimeters long, and it's also housing our payload subsystem in the nose cone. So I'm not sure if you can see, there's a bulkhead right there, and that's what connects up to it. And this shoulder is 1 caliber, and it's going to connect to the upper body tube, and it's going to be riveted. So that's how it's staying secure in flight. For the payload, we're just doing a bolster payload. It's just like dead mass. There's no scientific things. We've got these fiberglass bulkheads. They're about 2 mil thick that hold it in place. And then the idea is, since it's just a bolster payload, we can just slide. Let me try to keep the orientation. Slide stuff out just like that. And okay, when did that happen? When did that happen? All right, that's not a good look. Sorry, I've no clue when that happened. Cool. That's the payload there, and then there's a hole in the top bulkhead here, and then this is where we can add any more ballast weight into the nose cone. So if we need to increase the stability of our rocket, and from memory, so far we need about, I think, 1.5 to 2 kilos of extra ballast just to help us weigh down the rocket so we don't overshoot 10,000 feet too much.
Okay.
Yeah, that's the nose cone. And then it's just the same sort of reverse process, sliding it back in.
Yeah. How much does the payload weigh?
2 kilograms in 3 1U CubeSats.
Okay. Continue.
Yep. This is the upper body tube. So you're looking, this is the fore end, down there's the aft end. If you look from this perspective, that's the recovery bulkhead, and then on the other side, that's the U-bolt where it goes in. You might be wondering, why is there tape there? Originally in the design, we had these 4 rods of the payload subsystem actually up here or down here in the upper body tube, but then we decided to change it so that we could increase the stability of the rocket. So then we patched up those holes using 24-hour epoxy.
Okay.
That's pretty much the upper body tube. And then, so you get nose cone up here, payloads a bit in there, and now you've got your drogue parachute in here, and I'll pass to Greta.
So a question, guys. The recovery harness attaches to the U-bolt coming out of that bulk plate that's epoxied halfway down that tube. Is that correct?
Yeah, just in there.
Yeah. Is there a fillet on the aft edge of that bulk plate?
Yes. Fillets here.
Yes.
I couldn't quite see it anyway.
Right, yeah.
You might just.
Oh yeah, there are fillets on the aft section right here.
Okay, so you've got a nice beefy fillet on that side. So
Yeah, we've
slide down.
We've applied a pretty solid fillet around the perimeter.
Is there a specific value you want us to like go for? Like,
Well, if it was a rocket I was building, I'm just talking and Bill chime in here. I probably um, use some thickened epoxy about the consistency of peanut butter, and I'd lay a bead of it down at the junction of that bulk plate and the body tube, and then I'd run my index finger around so that there's a radius of about maybe 3/4 of an inch.
So
Just
like a finger's width, you would say
yeah,
roughly. Yeah,
yeah,
I think
something
got
like
we
that.
pretty much have laid it up to about, I guess, for your fingers width around both the edge, around the edge. You
Yeah,
personally use like a coin as like a nice smooth,
yeah,
like just to smooth it out. But you're right, we do lather a lot around the edges.
Okay,
good.
All right, so
good.
we'll move on to. You asked to keep talking about the parachute.
Sure. Since you're here, go ahead.
Yeah, cool. So just in here, we put our main parachute. So our main is a 9-foot parabolic that we've constructed ourselves based on Rocketman designs. It's this one here, and we wrap it in a Nomex blanket. We plan on folding it using the accordion method to make sure it's not getting tangled as it gets pulled out. And then we're attaching it to our shock cord using these swivels and quick links. And then we've got about 8 meters of shock cord that we attach to the ab bay and the upper body tube.
Okay. Okay, so 8 meters. So how far down that is your main parachute attaching?
A third of the way down.
Okay. Okay.
Cool.
And what are you using for your shot? Or you said it, but I spaced it.
Oh,
What did you
Kevlar.
use? Okay, for your shot cord?
Yeah.
Okay. And how are you folding your shot cord?
We're like zigzagging it into the upper body tube and then placing the parachute on top. So the parachute comes out first when the
Okay.
shock cord's pulled.
Do you pre-tape the bundles of the Z folded shock cord?
We haven't previously, but we're thinking of having it pre-taped for convenience this time.
Yeah, so Bill chime in, but I would typically do 6 loops. I can show you a picture later.
Okay. Yep.
And blue tape on either end to make them, maybe 10 inches long or something like
Yeah,
that.
cool.
Yeah.
Yeah, thank you.
Yeah, that's all, technique that yeah, I mean there's lots of different ways to do it, but that's basically the way I do it too, so.
Yeah, cool. Also, just on the note of the shock cord, we've taped the bits of the shock cord that are going to rub against the fiberglass to protect that.
You can also put a 45-degree chamfer on the inside corner so it's a little less sharp.
Yeah, okay.
Yeah,
cool.
we can do that.
Yeah, cool.
Yeah. The other thing that people have done in the past is to right at that point where the shock cord would rub up against the lip there, people will also, use some kind of like a piece of foam with some, a couple wraps of duct tape around it or something like that, just to kind of, help, prevent the zipper and the B to make sure that that edge of that tube doesn't kind of saw through your shock cord.
Yeah.
But again, that's just a suggestion.
Yeah, okay, cool. Thank you for that.
Okay. How about your drogue? What you got for your drogue?
Oh, yeah. So our drogue in our lower body tube, we've got this one here. It's a 2-foot iris parachute that we also made using the Rocketman design. The folding technique, the quick links, the shock cord is all the same as the main. So this is it here. And this will be deployed at apogee.
Okay. What are you using for your how much are you using black powder for your deployments?
Yeah, so we've got our primary deployment charge is CO2. We're using the Double Eagle rocketry kit from Tinder Rocketry. and we're
Okay.
using 38 grams for each deployment. So that was quite a few ground testing that went into that. We tried initially with 16, didn't work. We tried with 25, didn't work, and 38 we found is successful. Our backup charge is, I might show you guys actually. The backup charge is black powder, and we're going to use about 4 grams of that based on ground testing. So this is the black powder canister that we're using. We just put the black powder in here, fill it with dog bath so that it's compact, tape it off, and then have it e-match into our ab bay. And then here is our CO2 system
Okay.
with just the single e-match.
Okay. So since we got your electronics bay out, why don't you walk us through that? What do you how do you get it arranged, and
Oh,
tell us about
yeah.
your electronics here.
I mean, yeah, so we got our COTS altimeter, which is a telemetrum. And then we've got our ESRA one, which is actually over there, called Aura. Yep. And then you can see we're using like locking connectors and everything. And the SRAD is being powered by an 18650 cell to remain compliant. The telemetrum will just be powered by it's provided LiPo without any cell protection as required by the manufacturer. And if we come back over here, on the back we've got the featherweight tracker, which is going to be mounted here. And again, that's going to be powered by its manufacturer LiPo. And then for the ground station, obviously we're using featherweight ground station with a 915 megahertz Yagi. And what else do we have?
We also have a video system,
Oh, yes.
and that uses this Wi-Fi modem, and it operates on 5.8 gigahertz. And that's going to be used for our participation in the live video challenge.
Yep.
And that system will be powered by this board here, which basically just uses two 18650 lithium-ion batteries and this Raspberry Pi.
When you guys mount the batteries on the sled, what will you do to secure it? How will you make sure it doesn't come out, with high G forces?
Oh, yes. There's going to be like some wire that will be attached to it, basically. Because yeah, you're right. This holder is not adequate enough for high G forces.
So maybe some zip ties or,
Yeah, it will just go like
tape.
around the battery.
Yeah. Same thing with your 9-volt. You're going to use that for your Raven, right?
Yes, we have a 9-volt holder, so it should be good.
Okay. So what is your sled made out of?
Oh yeah. So this is the board, and we've already set up this is how we plan to set up the avionics, and then we've laser cut the holes. This is acrylic here. In the past, we've used 3mm plywood, but we've decided to go with 3mm acrylic, and the reason pretty much is that because it's like clear, it makes it a lot easier for us to set up all the avionics, make sure they're all attached, and see where all the wires are going. And then they're held in place on either end by these two 3D printed brackets. So each board kind of, if you can picture it, slides into a hole. There's more holes here where these two, I believe the M3 rods go through, and that holds that in place. And then the brackets are what then attach to the M8 threaded rods, which run up and down the avionics bay.
Okay. So your brackets, what did you print them out of?
PLA.
Okay. How much stress do you anticipate that those are going to undergo in flight?
For that, we've we're using our experience that the same material was used for our SAC 2023 rocket. So we're assuming similar forces, and we have pretty much a very similar design. So we don't really have a numerical value for the amount of stress they will have. But based on our experience in 2023, the PLA brackets did survive. So we are using that as our reference point.
Okay, well, previous tests that works. What infill percentage are you using for that?
Oh, I'll have to get back to you on that one, mate. We did 3D print these brackets more than a year ago now. The design's been very stable. So
Okay. Yeah, I mean, yes, I mean, it's probably like you said, you're using it off of a tested design, but we've had problems, or teams have had problems in the past, especially with PLA in the heat. It tends to get fairly brittle, and I've seen more than one team in recovery pull open their rocket and have the PLA pieces come out, in just pieces, as opposed to and how the whole thing stayed together. I had no idea, but that's just something that I'm based on my experience in recovery. I've seen that more than once, so that's why I'm asking the question. But if it's you're based on a tested design, that's okay. But just be prepared at the when you get your safety inspection at the convention center in Midland, that your inspectors are going to ask you about that. So make
okay,
sure
yeah,
you have that infill percentages and everything else that you've that you did in the past.
yeah,
Ju-
yeah.
A small question from my side to be sure I understood correctly. The acrylic piece that goes into the 3D printed clamp at one end, is it supported on the other end or is it freestanding in the air?
No, it's supported on both ends. So there's the nut on bolt on that side, and there's another one on this side.
Yeah. Okay. And that's pretty rigid?
Yes.
Yes.
Okay. All right. I'm good. Thank you.
I
Okay.
guess the only things to say for the avionics bays are bulkheads are made from 9mm plywood, just like in the nose cone, upper body tube, lower body tube, same M8 U-bolts made from steel, and then this is the housing of the coupler, and both of these are 1 caliber in length.
Okay. And what kind of switches are you using to turn this on?
Yeah, so we're using these custom-made screw switches, which we've got like a 9-lock nut on the back, and we're using these because they're using these like connectors we've standardized, which have a positive locking mechanism, which is compliant.
That means that it will not be able to vibrate out of place.
Yeah.
And also the nylock nut will not be able to vibrate out of place either.
Yep.
Okay. Right. So you don't have it all together, but just one thing to be aware of when you get this thing all assembled. Make sure that you when that rocket's going to be on the rail, that you're going to be able to access those switches. Every once in a while we'll have a team that lines everything nice and their entry holes for their switches are lined up with the rail buttons, which means they're right up against the rail when you got it on there, and then you got a problem. So that's just something to be aware of. Make sure that it's that your uh, uh, switch entry points are on the opposite side from the rail buttons, just to make it easier on yourselves.
Yep. Great point.
Yeah, you're chuckling, Brett.
Well, I made this mistake big time on a rocket I still fly, so
Oh,
I have to turn on the tracker before loading it on the rail. Otherwise, you can't get at the screw. So
yeah.
it's humbling. How did that happen? Don't
Yeah,
know.
there you go. Yeah. So it happens to all of us. But
Yep, it sure does.
okay.
Okay.
So anything else you want to see as far as the avionics bay there, Brett?
Could you show us a up close of the bottom and the top of the apogee plate?
Yeah, there
App-
you
Sorry, what's an apogee plate? Might be a different synonym over
The
here.
plate that has the apogee charges on your av bay. Pardon me. I think you just had it right there. Yeah.
This?
Yeah. Okay, perfect.
go.
Any questions on that?
So how do the wires come through to the charge cup again? Could you just refresh my memory?
So we've got the CO2 system in here with the E-match feeding out this side,
Yeah.
and then we feed it in this hole here into
Yeah.
the ab bay. We do need to drill another hole in here where you can see where it's
Yeah.
been marked here for the black powder. So the black powder E-match head will be in here, and then it's going to feed out into here and then connect to the ab bay.
And how do you seal around the E-match wire?
Yeah, this is a used E-match, which is why there's so much wire showing,
Yeah.
but we use a bit of blue tack to pull it through and keep it covered.
Okay. So the hole in the ab bay plate, you're going to put like poster tack around it. Is that what I understood?
Oh, you mean this hole here?
Yes,
Yeah.
correct.
Yeah, if there's a bit of a gap, we'd put a bit of blue tack, but it's actually quite tight. Like it's quite tight to feed it through. So by the end, there's not really a gap.
Yeah. So I'm kind of picky about those things. So you might consider like poster tack. It's this gooey stuff
Mhm.
you can use to put posters on walls in meetings.
Yeah, yeah.
And
Oh, sorry, that's not what I mean by blue tack. Yeah,
yeah, okay. Blue tack. Is that what you were saying?
Yeah,
yeah.
that's the Aussie one.
Okay, sweet. Okay, we're agreeing. Okay, so something like yeah.
Yeah.
And then those wing nuts won't come loose, will they?
No, they'll be tighter
No.
on there.
Yes, we've
Yeah.
just got them loose in case you wanted us to
Yeah.
take it off just a
I
bit.
understand. And then what's the other side look like? Can you show us that
Yep.
one?
It's
Exact same as the other
yeah.
side, really.
All right, now so the opposite side of the one that you're showing us now,
Oh.
could you see?
Like there.
Yeah. Yeah, okay. So you've got
Get it.
you got a plate for the U-bolts. Yeah, nice. Okay. Looks good. Thank you. I appreciate it.
And just while we're talking about bolts and the hardware, what's your stress rating for your quick links and your swivels?
Oh, I'd have to get that up, but everything was rated quite highly. I'd have to get the specific values for you though.
Okay. Yeah, you'll want to know that because you're going to get asked. But they look plenty beefy to me, so
Yeah.
I don't think there's an issue there. But okay.
Everything previously we try and rate 50 times, but I can get the specific values. I don't know them off the top of my head.
All
Can
right.
you can you can you show the swivel arrangement you have for the shock cord that connects to the booster part of the rocket?
Oh, which part, sorry?
The booster part.
The booster part.
Like lower body tube where the motor is
Yeah,
housed.
yeah, exactly. The bottom part. I just wanted to see what that recovery harness section looks like.
Yep. So there's also M8 U-bolt there.
And then we use one of these quick links to attach to the shock cord.
Okay. But yeah, so what we're asking is the swivel section. Do you have like a swivel that it attaches to the parachute there, the shroud lines?
We were only using swivels to connect the parachutes to the shock cord itself, not the shock cord to the rocket.
So my 2 cents, and Bill, I'd like your opinion. If I was to put a swivel in, I would put it at at the at the bottom of that shock cord where it connects to the motor part, because
Yeah.
that's where I've typically found most of the twisting because my fins weren't quite on straight. I've rarely found issues with needing a swivel for the main or the drogue as they're connected to the shock cord itself. So
Do you
if you have a swivel, I typically put them down for the projects I fly because that's where I've seen most of the twisting.
do you think it's worth having a swivel at each connection, or just at the lower body tube?
Well, in my experience, after boost, you can have some rotation of,
Yeah.
of the rocket, and at apogee, you may still have some twist going on, and then during descent, particularly under drogue, sometimes the booster keeps twisting around. So that's where I put my swivels. I don't really worry about the main and the drogue as much.
Yeah, cool. We've definitely got a couple of spares, several spares actually, so we'll definitely do that.
Yeah.
Yeah, and the other thing that'll happen and is that especially on deployment, you've got the booster, may still be spinning,
Yeah.
but also the aerodynamic force will sometimes cause that parachute itself to spin as it's coming out.
Yeah.
And then, so then, having that swivel down at the base tends to, just allow that to untwist itself without having everything spinning around. Uh, Believe it or not, I actually had that happen to me in a static line parachute jump
Oh,
back
my.
in my youth, where when the deployment bag for the parachute that I was wearing spun around, and when the thing finally opened, the shroud lines were twisted all the way down, enough so that it forced my head down.
Oh my
And I
God.
had to, pull this thing out and bicycle to untwist myself underneath the parachute. So, yeah, it even happens to people. So,
Yeah. No, it's a good point. We will definitely attach a swivel link to our base then.
Oh,
I,
did we?
Oh,
I just put up a picture that I promised. This is how I
oh,
tend to bundle my shock cords,
yeah.
blue tape, and make sure that if you do this technique, I like to have the two cords exiting on the same end so that the force on the shock cord rips the tape apart.
yeah,
Okay, that's
cool.
all.
Thank you.
Anyway, that's one example.
Okay. All right. So, we're down to show us the, how many, shear pins are you using for your two sections there for your ejection?
For each separation, we're using 4 shear pins. They're nylon 440s.
Okay.
So there's actually one in there right now.
Sure enough.
The head of one from our last ground testing.
Okay. And since I see the rail button right now in the picture, tell us about how you've got your rail buttons attached.
Yep. So these rail buttons, I believe they came from Aerotech. We bought from Aerotech. Do you remember? Do you remember what the specific product name was? Rail buttons. What the
So 15 by 15.
15 by 15, and then on the other side they provide essentially. Can you hold this down so the rocket doesn't like tip and so I can remove this? They provide essentially a like metal plate on the other side that it sort of screws into on the top here. So I can unscrew it if you like, and then
No,
the center,
it's okay.
also
So
there's
that plate's just epoxied on the backside there to give it some strength there.
Yes.
yes.
Okay.
So this one's a bit more messy. You can see there's like epoxy there.
Okay.
And those look like they're about like a meter apart or something.
Bit more than that. So we tried to put them. The guiding principle for us was we wanted one nearer to the bottom for launch force with the rod. And then up here, the center of gravity is around here, but then also the problem is we've got the avionics bay coupler pretty much right on there. So we tried to move this as far as possible up without interfering with the avionics bay coupler, because from what we read online, the idea was you wanted the higher rail button to be above that center of gravity. So it's actually pretty tight when it comes right off the rod, but that's why we put it up here.
Okay.
There wasn't really
Okay.
much room to put it anywhere else.
Yeah. So how far from the so you got about like that's at about a meter. So that's when you did your departure or when you did your exit velocity calculation, what did you use? What length of what effective length of your launch rod did you use?
We had a
17-foot divided one.
we used the fact that, are you saying the rail length that we used?
Okay. So the point I'm making here is that so when can that rocket deviate from being on the rail, right? It's when that that
It's when
top
this,
rail button and
yeah,
then so when that top rail button leaves the rail because now it can pivot around that bottom rail button.
yeah,
So your effective rail length is the 17 feet of the ESRA rail minus, the distance between your top and bottom rail buttons.
yeah,
So it's really only about 14 feet or thereabouts. And
yeah,
so that's, when you calculate your rail exit velocity, that's the value you need to use, that point where that top rail
yeah,
button leaves the rail, because then the rocket's free to, at that point, the rocket's starting to fly aerodynamically.
yeah. All right, good. All right, thank you for pointing that out.
Would you recommend then it's better for us to move this down, like further down here, so that we longer
Well,
longer.
okay. So remind me, what's your rail exit velocity?
So currently it is 28 meters a second.
So you could move it down a little. I'd be comfortable.
Yeah, it's a little on the slow side. It wouldn't hurt to move it down.
Yeah, understood. Yeah, we'll try to definitely look into that.
No, it should be easy because you can just unscrew it.
Yeah,
It's fine.
it should be perfectly fine for us.
Were there any more questions on the rail button?
No,
No.
just make sure that they're, going freely and everything like that. Don't tighten them down too much. We've had teams in the past who've shown up and they've tightened those things down so much that they actually deformed the rail button a little bit so it wouldn't fit on the
Right.
rail until they loosened them just a little bit. So just
Okay.
something to
good
be
tip.
aware of. Yeah.
Thank you.
Okay. So why don't you tell us about your how do you have your bulkhead top bulkhead fastened in there?
Yep. So again. So it's again just an epoxy like fillet around there.
Okay.
Yeah.
And
Same as upper body tube.
yeah, are you using any screws to attach that into? Also, are you using the fillets to hold it in?
No, we're
the
just
fillets.
using the fillets.
Okay.
Um,
Okay.
We secured it additionally using screws, so we drill it from.
like there, you can see all the way through.
Is that something that you've seen work well in the past? Is adding additional screws?
I would tend to reinforce a little more myself. Some screws wouldn't be a bad idea. If something really bad happens, you just don't want that to come out. So everything you can do to minimize separation of the parts is good.
Yeah. A lot of teams will and just use tap the holes a little bit so screws will go flush mount
Right. Okay.
on the outside there.
Yeah,
Are
you can
you
use beveled screws. Mhm.
bulkhead directly in front so it doesn't so the screws act like a stop?
Yeah, or you could put it into the bulkhead,
Yeah.
maybe 2/3 of the way up.
That is you say that's way I think I've seen that other teams' designs where they've screwed directly into the bulkhead.
Yeah.
Yep.
You
Yeah.
could put your bulkhead's plywood, correct?
Yes, 9 mil plywood.
Yeah, you can get screw in, if you want to be really fancy, you can put screw inserts in from the outside. So, but I don't think that's necessary.
Yeah. Yeah. Just just used beveled or countersunk a little bit into there. Like Brett said, you could use screw inserts if you wanted to, but really, that's you're that's kind of overkill. But you know,
Okay.
okay. So tell me about your fins here. How do you get them attached?
Yep. So the fins, and I can probably show you. So I've actually got a photo just on the computer to help you. So we've got fin tabs on our fins that then have slid in here. So that's the first sort of like way to attach it. And then also on the fin tabs, as well as on the outside, we've got epoxy attaching the fins. So I guess there's sort of 3 points of contact, the fin with the outer body tube, and then the fin tabs with the 2 centering rings right here, and then the fin tab with the motor tube on the inside, and epoxy on all of those.
Okay. And did you do any kind? Did you do like a tip to tip or partial tip to tip way up there? Is that what I'm looking at?
Yes.
So you did like 1 layer or 3 layers? How many tip-to-tip layers did you do?
Could you define what do you mean by partial tip to tip?
Well, it looks like the way it's looking, it looks like you've got, or at least that top layer of fiberglass doesn't go all the way to the ends there.
Oh, you're saying like this top layer here doesn't look like it goes to the end?
Yeah, right.
Oh, okay. That's because so our fins are a diamond airfoil, so it's part of, I guess, sanding it to get to that diamond airfoil. That's why it no longer goes all the way to the end. Is not sure that's
Okay. So your airfoil is beveled on both front, fore, and aft, and then on the tip cord there. Okay. So how many? So when you did your so so how many? So did you do a tip to tip fiberglass layup then over it, or is that just the fins itself that I'm looking at?
So what we did, we did the fins separately. So we laid several sheets of fiberglass together. We then cut it out and then split them in.
Okay. So you basically got a sandwich of a couple pieces of fiberglass.
Yes.
Yes.
Okay. And those are bonded together somehow?
Yep.
Yes, with the same epoxy resin mixture that we've used for the entire body tube. So it's all the same fiberglass supplier, same resin epoxy supplier, same ratio.
And so there's a good point to talk about your fin flutter calculations.
Our fins are, I'll bring up data, technical report. So our fins, we used the latest method, the Bennett method, in the Apogee Peak of Flight newsletter released. Oh, why is my computer playing up? Released Apogee newsletter issue 615 because you don't need shit. I'm just reading it because, and the reason for this is because in that article, the author Bennett discussed how the previous methods by Howard and Saar had overestimated the fin flutter velocity by 1.41 times. So now using the new calculations, our flutter speed is 482 meters a second, or Mach 1.41, which is significantly higher than our maximum estimated speed, which is 272 meters a second. And this occurs at an altitude of 616 meters from our simulation.
Okay, so you're just what? So
Our
your
safety margin's 80%.
mix, yeah, yeah, and so your maximum velocity is what? Upper transonic there. Just doing the math in my head.
Oh,
0.85 Mach or thereabouts.
72 divided by 343.
Yeah,
Yeah,
so
the 0.8.
so our maximum speed's at 0.8 Mach.
Okay. All right, good.
Yes.
Okay.
And then we've got very, very thick billets on the fins.
So one of our learning lessons that we had from SAC 2023 is what we found is in the Albuquerque heat, fillets that we had were becoming a slightly bit brittle. So we know some cracks. So we decided to now put a bigger fillet across, as well as roughen up the surface along the upper body tube so it has a better contact.
Yeah. Yeah, I mean, because really, it's, you've got essentially a mechanical bond there, and
Yeah.
a more surface contact area you can give for that epoxy is better. So that's a good practice to rough that up a little bit before you do the epoxy.
Yeah. Yeah.
Yeah. And Midland's not going to be any cooler than the spaceport was.
We checked the weather forecast, so
Yes.
take it down into consideration.
And I guess final thing. So this is our own 98 mil motor casing from Aerotech, RMS 98/7680 from memory. Let me real. Yep, 98/7680. So we'll be bringing this with us to the US, and then we also have in our possession the motor retainer purchased from Aerotech as well. And those are attached to the lowermost centering ring / bulkhead by these threaded inserts. Currently we don't have the screws in. That's because we were going to do a test launch 2 weeks ago, so the screws are in the other test launch rocket.
Okay. So you said you were going to do a test launch 2 weeks ago. Are you going to try to get a test? That sounds like you didn't get it done. So
Unfortunately, there's been a lot of issues with getting motors to Australia for the past 2 years. So we actually found out not even 24 hours before that our motor still hadn't arrived. So we weren't able to do the test launch.
So we obviously had a really big issue with Aerotech last year. So we ordered our motors last year, February, and Aerotech have had a lot of shipment issues, especially coming to Australia. This has actually been one of the major issues last year. If you guys weren't aware, we had the Australian rocketry competition, and that was actually cancelled because none of the teams within Australia actually got their motors from Aerotech. So we're still...
Oh, holy smoke. I didn't know that.
Yeah, so that was why, like, the motor that we were meant to get for the previous year's competition, we never arrived. So that's why we've never had an opportunity this year to test to go for a test flight. But we've had a rocket that's been pretty much ready for a test flight for a very long time.
Okay. Right. And how are you getting? So you said, are you getting your competition motor delivered at the site, or?
Yes. So we went through Wildman Rocketry, which I think is the official vendor for IREC. So we bought that motor in November or early October last year. So we got M
1845
M1845 through them, and we've paid all done deal with that so far. So we've done everything with that. So we will be So the motor will be arriving on site, as with I'm pretty sure all the other competition motors from the top of my head.
Yeah, pretty much. Yeah.
So I think we've done a similar process with when we went 2023. I think it was back then we did it with Animal Works. I'm pretty sure.
Yeah.
So this time we went with Wildman. I'm pretty sure we got from the town hall that was released. They recommended that, so we went with that pathway, that vendor.
Yeah. Yeah. Animal Works had some internal issues, I think, that prevented them from coming back for this year's cup. So that's why Wildman picked it up.
But in terms of motor assembly in 2023, we had really no issues. Animworks was they're very supportive throughout the whole process, especially with other teams. So we're expecting a similar sort of, I guess, like support from Wildman with that. But that's it. Yeah.
Okay. And let's see. Brett, do you get any other questions or thoughts here?
No, I think overall team looks like they've made good progress. You know, you guys need to finish up your Av Bay and all that kind of stuff, and there's little details, but overall, I think it's looking pretty good.
Yep, I agree. So do you have team? Do you have questions for us?
I had one question specifically regarding the.
Oh, you didn't know me.
But yeah, I had one question, which is regarding the paint that teams have used in the past. So what initially in Albuquerque, we went with a very much a black dominated rocket. And we noticed that it was kind of hot, so that black color was slight uncomfortable. Would you recommend avoiding colors like black, or would you avoid gold or yellow because of the desert yellow? Is there certain colors you would avoid teams use?
I would avoid black.
Yeah, I would definitely avoid black or any kind of real dark color. Uh, just because there's a chance that your rocket may sit on the rail for a while, depending. Um, one of the things about the new site is that we have less restrictions, and so look, we've got the locals are actually, building us extra roads and doing some stuff like that to help the throughput. So I'm thinking that the process of getting out to the launch rail and getting out to the pads and then getting the salvos off is going to go quite a bit smoother than it has in the past, which hopefully will prevent people from having their rockets sit there. But you still got to take that chance. The other thing is that there's not a lot of the same kinds of vegetation at the launch site that you saw at the spaceport. So, this is oil field area. So it's pretty flat, and there's not, like I said, not a lot of tall vegetation just because of the oil drilling work that's gone on in that area. So that's you know, uh, so that's one thing you won't have to worry about quite as much. But I mean, lighter colored rocket, something bright, uh, would be, probably ideal from my point of view. Yeah, I would definitely stay away from a, tan or, anything, that would, blend in, with that stuff. But other than that, it's up to you how you want to do it.
All right, thank
Oh
you.
yeah. Also, do teams have line of sight to the pads?
This
Yes.
year they should. Yeah.
Yep. And
Yeah.
and for the live video ingest point, do you know if it's like it's obviously like not, but like is there a clear view to the sky in the live video ingest point?
As far as I know, yes. I
Yeah.
mean,
Okay.
but the person to double check that the video coordinator Logan Herrera, and if you just ask a question on Hero X and tag Logan, he's usually pretty quick about responding to those things.
Yeah. Thank you.
Yeah, because he's the expert for all things related to the video and live stream.
So
Yep.
I forgot I had one question. For your motor guys, do you have to do grain bonding?
Uh, ooh, grain bonding for our motor.
I don't think we do require grain bonding for the M18 for that motor.
Okay.
But if we've personally haven't had much experience with grain bonding in the past. Most previous motor that we chose did not require grain bonding.
What's the motor again? It's an M118.
M1845.
An 1845.
Okay, keep going.
So that's why we've assumed there won't be any grain bonding required. When we purchased the when we purchased the motor, there was no specific mention. But from the top of my head, I think grain bonding, correct me if I'm wrong, is a 24 to 48 hour gluing process that requires a certain glue,
Yeah.
which is, I think, I can't remember the full chemical compound.
Yeah. So basically, I think just to make sure you got your enough lead time because you don't if you do have to do the grain bonding, you got to do it at least 24 hours prior.
Yeah.
And so but you ought to be able to go to the Aerotech site, find the specific literature for your motor, and double check that whether or not you need to do the grain bonding or not. And if you don't, then no worries. And if you do, then at least then you're you know what your timeline has to be.
Yeah.
Yeah.
And, if you guys could check that and let me know if it does. And I'd like to work with you to make sure we're ready to do that, and I'll help you out with it on site. Okay.
Thank you so much, Brett. That'll be appreciated. We'll confirm and send you an email tomorrow if that's okay.
Yeah, it's no worries. Just if we're going to need to do that, we need to prepare in advance. So sounds good.
That's good. Yep.
Okay, good. So so where are you all planning to stay for the competition?
So we arrive June 7th in Midland, and we'll be staying at the Midland Hotel in directly in the city for one.
It's next to the airport.
Pretty much right next to the airport, for one night. So in June 8th, we'll be traveling to Fort Stockton, where we have an Airbnb for the remainder of the competition until June 14th. So we'll be traveling from Fort Stockton to the convention center on the Monday, I think, of the competition, and then we'll be at Fort Stockton for all the subsequent days.
Okay, and so you've got a good just make sure from Fort Stockton to Midland, that's a good 4 hour drive or thereabouts. So
Around 1.5 hours.
I think that's what we double checked.
yeah, okay. So just make sure you stay ahead of the timelines there,
Yeah.
because that first day is gonna be a long day for you. But yeah, that's probably a better choice for getting back and forth to the site. Um, how many people have how many members of your team are you bringing?
So we have about five members coming along from UWA, and we'll be
Okay,
staying throughout the night, throughout the fall competition.
okay. And how many of you are Triple E members?
All of us are Triple E insured and members, and we've done that for the registration process.
Okay, good. Um, and let's see. So of the ones people who are coming, how many of them have been out here before?
Can you say it again? Have been?
Went to? Did any of you come to the last year's
Previous?
competition?
None of us have. Currently, we do have one of the we have one of our mentors that we'll be meeting. She was at the 2023 competition, so she'll also be joining as a spectator.
Okay, yeah.
But
So
none
just
have.
just a reminder, it's darn hot. The sun out there is just relentless. So you need to be aware of that. You need to uh, dress appropriately.
Yeah,
Meaning basically if if I were to be out there, I would have long sleeves on. I'd have a floppy hat. Just to cover keep yourself covered up as
yeah,
much as possible. Yeah, Brett, you wanted to ring in there?
I was just agreeing with you totally.
Oh yeah, yeah, yeah. In the past, we've had people who showed up thinking that the way to beat the heat is to dress in as little as possible, which is going to guarantee you one heck of a sunburn and and a very miserable trip
yeah,
after that. But so so we're going to be Ezra's providing the tents so it'd be large circus kind of tents with your tables and everything like that. So that's all provided, but you all have to bring your chairs. So I know a lot of the overseas teams who are coming are planning on hitting the Walmart in Midland or wherever to buy chairs on site, but that's you just got to make sure you bring your own chairs.
yeah. Do you know from top of your head how many tables each team will be allocated to? That's something I don't think we can really find much information. Is it
Um,
just one, just like
One garden table.
yeah, one garden table sort of size, a similar size to what you kind of see here?
yeah, I think I, I'm pretty sure that there's going to be at least two of the long tables. So basically, what 3 meters long. Um, there should two of them. I can, that might be a good question to ask on Hero X, but uh,
Yeah.
previous years, I think they've allotted two, two or maybe three tables to teams depending on team size.
Yep, understood. All right. Thank you for that. We'll definitely clarify on Hero X.
Yeah, but I think they're going to be, ample tables. I don't think that's going to be a problem. Again, and the other thing to remember is, hydration, drink, drink, drink. Make sure, you have, some kind of cooler and lots of water. They will have water out there on site. But it's probably going to be in a water buffalo, so it won't be the tastiest stuff. So I'd suggest you buy a lot of bottled water while you're out there. Uh,
Buffalo, like you mean the animal or like a
oh, I'm sorry. It's a military term, but basically a tanker truck full of water. So
Okay.
yeah,
Yeah,
so big. Yeah, sorry about that. Yeah,
No.
big. Yeah, so they'll have a tanker truck with water in it, which, is certainly going to be drinkable, but it won't taste the best.
Yep. All right. We'll
Okay.
definitely prioritize hydration. I mean,
Yeah.
yeah. I mean, Australia's naturally we're very the word sun smart, so
Yeah.
we eat. So we have very similar procedures to what they have in SAC that we follow in Australia. So it's nothing too unfamiliar for us. But yes, we'll definitely prioritize that, especially learning from experience from 2023. So that was a good reference point. The last thing I think, Brett, just wanted to say, we do believe the 1845 does require some grain bonding.
Okay, so here's what we do. So as not to spend too much time on this call, follow up with me, send me the instructions that you do find, and let me take a look at it, and I'll be back at you by email, and we'll figure out a plan.
Yep, perfect.
Okay.
Thank you so much. Yeah, we'll get on that ASAP.
Yeah, no worries.
Okay, good. All right.
And you guys bought igniters for your motor as well?
I'm gonna say no because I don't remember saying yes. We just went on the website, selected motor, and buy.
No, I don't think
So
we
it doesn't come
bought.
with the kit, then no.
You might check to see if you could still place an order for a couple of the dual match igniters that are ESRA approved that Wildman has.
Yeah, cool. We'll get onto that ASAP.
Yeah,
Okay,
they may have them, there on site, but it'd be better to pre-order it, I think.
Yep. Thank you for me. Place
Yeah,
it.
good put there, Brett. Okay. All
Oh,
right.
the last question I have, because I'm looking at it, why do you have a Yagi on your featherweight ground station?
Yeah. Honestly, it just looks cool. I know you can just use any old like dipole, but yeah.
We have a tradition within our avionics team to use a Yagi purely just for photo reasons, but there is no other technical reason why we choose this over any other system.
Okay, and you've flown with a featherweight and one of those Yagis before? It works okay?
Yeah, it does.
Yes, we have done launches here in Australia.
Okay.
Using it.
Yeah, we have. As a matter of fact. But I know it advertises that you actually don't need the whole game. You can just use the 1.65, whatever.
Yeah, the little stub. Yeah, okay.
Yeah.
All right.
So we can say it's for marketing purposes. We'll do that.
All right. Give somebody on the ground something to do. I get it. All right. That's all on my side. At the end of the recording here, I will send this to ESRA, Bill.
Yes. Okay. I was just gonna say that. So you read my mind here.
Yep.
Well, it looks good, team. I think I don't have any concerns or anything like that. You've got a good rocket, and a good plan. We gave you a couple minor tweaks, but that's all they are. I don't see any showstoppers, and so I'll be signing you off for your video review as soon as we get off the call. Perfect.
All right. Thank you so much.
Yeah, and then I would ordinarily I'd be looking forward to meeting you all, but unfortunately I've got open heart surgery the week before the competition. So I'll be watching via live stream. Looking forward to seeing your rocket fly and seeing a good result for y'all. Okay.
All right.
Any last questions or comments anybody has? Yes, sir.
All good from my side.
All good from here.
Thank you.
All right. Well, I'm good too. So, all right. Well, thank you very much for your time. Good luck with your finals. I put my professor hat back on. Good luck with your finals. Study hard.
All right, thank you for that. Yeah.
And we will, good luck and clear skies for the competition.
Sweet.
All right. Thank you so much.
Thanks a lot. Hey,
Ciao.
thanks, Brett.
See you guys.